Thank you so much for joining this lesson. We shall be discussing the Kisii Diocese Schools Joint Evaluation 2025 in preparation for the KCSE 2025. This mathematics paper 1, and we shall start with the section 1. Remember to subscribe. Remember to share so that you may invite a friend to this powerful broadcast. Thank you. Thank you for joining. You can comment. Let's know where you're watching us from. Let's know whether you're getting something from Shifting Grades Online School. Remember our consultation line 070415 3366. That's our line. You can reach out anytime for consultations. Remember our upcoming programs for the continuing students. If you are in Form 3 and Form 4, that is by 2026, we invite you from 10th of November to the 12th of December, together with your siblings in the junior school, so that you may join our serious program here, whereby we'll be covering the Term 1 work of 2026 via Google Meet. Very interactive, impactful, resourceful lessons. You reach out through the same number so that you may know much about our programs. Otherwise, thank you for joining us in this revision as we wind up for the KCSE 2025. Without using logarithms or calculators, evaluate 0.04 multiplied by 0.54 times 45, then over 0.81 multiplied by 0.012. Let's start by checking the number of decimal places from both numerator and denominator. So on the numerator, we've 1, 2, 3, 4, 4 decimal places. Then on the denominator, we are having 1, 2, 3, 4, 5. That means we multiply with the maximum number of the power of 10. That will enable us to do away with all the decimals. And remember, we cannot multiply with different figures on the numerator and the denominator. Therefore, we multiply with 100,000 so that all the decimal points in the numerator and in the denominator are cancelled. So when we multiply with 10,000, remember, 100,000, we shall have 4 multiplied by 5, 4 multiplied by 4, 5 multiplied by 10. After multiplying by 10,000, after multiplying by 100,000 on both sides. So 100,000 and also 100,000 here. So you can't multiply with a different figure so that the expression retains its value. So after that multiplication now, at the denominator, we shall simply cancel all the decimal points. When you multiply with 100,000, you shall just cancel the decimal points. But at the numerator, they will remain at 10 after multiplying by 100,000. At this point now, remember we've been told without calculators and without logarithms. Okay, that means without math tables, in other words. So now we can check at common factors. For example, by 4 and by 4 here, we shall be getting a value like 3. So that 3 now simplifies by 3, 1, and by 3, we shall get 15. Then at this point now we can start working out, for example, by 9, we can simplify by 9, where we remain with 9, and by 9, we can get 6. 4 divided by 9, yeah, we get 6. Look at that. We can still continue simplifying. By 3, we get 3, and by 3, we get 2. Then by 3, we get 1, and by 3, we get 5. So this is 5 times 2 and times 10. That's 10 times 10, giving us exactly 100. So the final answer is 100. A very good question, whereby you just look at the common factors, you simplify them out without taking a lot of time. You pocket your 3 marks. Let's check number 2. Again, it's a question on simplification, but here we're having algebra introduced. 9x minus 4x power 3 all over 2x squared minus 3x minus 9. Let me first simplify the numerator, then later we shall get to the denominator, and after that we shall be combining to see what is common and what can simplify out. So from the numerator, ladies and gentlemen, from the numerator, we can see once we factor out x, we shall remain with 9 minus 4x squared. Then something that you should be able to notice now is that in the brackets now, we have remained with a difference of 2 squares. A difference of 2 squares. With a difference of 2 squares now, it can be factored out using the quadratic identities. Quadratic identities, that means now we apply at this point quadratic identities, whereby we know very well with a squared and b squared, this simplifies to a minus b, a plus b in any order. You can start with a plus b, a minus b. So if you expand this, you get a difference of 2 squares. Therefore, with that understanding now, we need x, then 3 minus 2x, 3 plus 2x. Now the denominator, okay, the numerator is fully simplified. Let's check now the denominator. We pack that answer there. We check the denominator. Let's check the denominator in this case. We can work with what we call a quadratic expression now, whereby we need a product of a times c. That's 2 by negative 9, giving us negative 18. Then we also check sum of the value at b, which is negative 3. Which two factors are multiplied to give us negative 16, but when added, we get a negative 3. If we consider negative 6 and positive 3, ladies and gentlemen, you discover that the product is negative 18 and the sum is negative 3. It's also good for you to know that for you to get these factors, it's good you simplify the product, which is 18. Once you simplify it, you'll be able to combine a few of the factors, the prime factors, and you see which one will give you the sum and the product that you need. Now look at the denominator now. It has to be re-expressed, starting with 2x squared. Instead of negative 3, we substitute with negative 6, positive 3. So minus 6x plus 3x, then minus 9 that way. In the first two terms, we factorize whatever is common. And we can see there's something common. Let me, that's my space here. That's 2x. We remain in the brackets with x minus 3. And then we proceed to the next bracket, whereby we'll be able to talk about what is common here. 3. Positive 3 actually. Start to remain with x minus 3, like that. So at this point now, we can talk about x minus 3. That is after picking the common factor in the brackets. Then outside the brackets, we're having 3 plus 2x. Outside the brackets, we have 3 and positive 2x, or 2x plus 3. So now the denominator is also fully factorized. That means we can now combine it with denominator, whereby we shall say that the combined now is x, 3 minus 2x, 3 plus 2x. Then everything out of the simplified denominator, x minus 3, 3 plus 2x. You see? This is a very good expression. So this one and this one are common. That means now we can talk about a simplified final answer of x, 3 minus 2x out of x minus 3. So that's now the final answer, fully simplified. Thank you for following. Guys, remember to subscribe, remember to share, remember to invite a friend as we continue preparing for the KCSE 2025. Yeah, this is the best platform ever. This one is the best platform. If you can't understand from shifting grades, I don't know what can help you. Please just remain loyal to this platform. Make sure you go through very many papers. Actually, this is not the only paper that we're using to predict the KCSE 2025. We have more than 100 full papers which have already been uploaded. Section 2s, section 1s. Some people are asking me to project section 2. But we have uploaded as many as you want, as many as you can't finish. So you can't finish actually going through all our prediction questions. Take your time and slowly go through question by question, video by video, as you listen to explanations. Now we are focusing on number 3. Please remember to comment. Let's know where you're watching us from. Let's know where you are watching us from. Let's know whether you're getting us clear. From wherever you are. Say hi. Let's know your school. Yeah, thank you. Let's know whether you still remember our program here. Please invite a friend who is continuing either in junior school or in senior school. We are having the best program ever. Very interactive, productive, and I'm sure people will appreciate what we are doing in this particular platform. Now find the equation of the line which passes through the point P, 1, 3, and is perpendicular to the line whose equation is 2y minus 3x equals to 7. The first thing that we're supposed to do here is to arrange the second equation such that it is in a format which can help us to extract gradient. And this is the format. Y equals to mx plus c. So we can first remain with 2y equals to positive 3x, and 7 is already on the right-hand side, so it's still positive. Remember, negative 3x, which is on the left, now becomes positive on the right-hand side. How do we remain with y? By dividing through by 2. So from this now, we can say the gradient of this line is equivalent to 3 out of 2. Whatever is the coefficient of x is the value of gradient. So whatever multiplies x, the coefficient of x, or rather, the value of m, is usually the gradient of a line, as long as the equation is in the format stated above. Now with that, we're supposed to know that for two perpendicular lines, this is the relation between the two lines. For two perpendicular lines, the product of their gradients is usually -1. Product of the two gradients should give us -1. If that is so, then we can get the gradient of the line which has been stated here. So there is another line perpendicular to this. What will be the gradient? We just supposed to know that gradient 1 multiplied by gradient 2 should always give us -1, as long as lines are perpendicular to one another. And something else that you're supposed to understand is that if lines are parallel to one another, then they have the same gradient. So if we were talking about parallel lines now, we would have already concluded that the second gradient is also 3 over 2. But now that they are not parallel, then we go for the relation for perpendicular lines. So now we will say this gradient, 3 over 2, times unknown m2 should give us -1. So we multiply both sides by, to remain with m2. We multiply both sides by 2 over 3. So -2 out of 3. That is our second gradient. With the second gradient now, we will use it together with a line with point P and another universal coordinate xy, so that we may express the gradient. How do we get gradient? Gradient is given by change in y over change in x. So -2 over 3, which is our gradient, equals to change in y minus the y coordinate, which is 3, out of change in x minus 1. So at this point now we can do cross multiplication. 3 multiplies everything here, and -2 multiplies everything here. 3y minus 9 equals to, this is equal, sorry, -2x positive 2. 3y can remain here, -2x plus 11. Is that okay? How do you remain with y? -2 out of 3, the value of x, plus, we are dividing through by the value of 3. This is 11 over 3. You know, it's good you put it as an improper fraction. So it's a mixed number instead of improper fraction. So instead of 11 over 3, we can have it 3 and 2. That's 3 and 2 out of 3. Yeah, 3 and 2 out of 3. So that is the final statement of the equation. Very good work. A very good question. That's a very good question. So please be vigilant when it comes to equations of straight lines. You can also find something from tangents and normals to a curve. Please remember to relate them using the same approach. A normal is perpendicular to a tangent at a given point. Equation of a gradient of a curve at a point equals to the gradient of the tangent at the same point, but now a normal is perpendicular to the tangent. So you relate them using the relation between perpendicular lines. When you go through the several papers that we've managed to upload, you will find questions that can help you understand all those concepts. Looking at number 4, ladies and gentlemen, as we continue wishing you success, guys. Success, greetings from Shifting Grades. Evaluate 81 out of 16 raised to the power of negative 3/4. You're supposed to read very carefully. That negative 3/4, some people may not see it, multiplied by 9 over 4 raised to power half, multiplied by 27 raised to 2/3. This is on indices. And as a matter of fact, this is a very simple question, easy to approach and easy to understand. Very simple. Very, very simple. So let's employ the laws of indices that we can remember. Let's look at this. The first index, you know, you just guided by the nature of the power. It leads to the law to be applied. For instance, when you look at the nature of the first power, it's a negative. So why don't we go for the negative law of indices? You see, negative law of indices that says, whenever we have a power raised to power negative, we need to take the reciprocal of this base and the power becomes positive. So with such a law stated, then it means we just need to take 16 over 81 instead of 81 over 16. And now the power becomes 3/4 multiplied by 9 over 4. And this becomes half. 27 raised to 2/3. Very simple. We have applied one law already. Now we go to what we call the fractional law of indices, because when you look at all the indices here uniformly, they are all fractions. All the powers are now fractions. All right? Now, when they are fractions, we apply the fractional law that says a power, a fractional power, mn or m over n. We take nth root of a, then everything now is raised to power m, meaning that we need the fourth root of both 16 and 81. Then after getting the fourth root, we'll be raising to power 3 multiplied by the second root, or rather square root of 9 over 4. Then after that, we shall raise everything to power 1, then multiplied by the third root, or rather the cube root of 27, after which we're supposed to square. We're supposed to square whatever we get at that point. We proceed now. Look at the next step. When I talk about the fourth root of 16 over 81, fourth root of 16 shall be 2, and fourth root of 81 shall be 3, raised to power 3, multiplied by the square root of 9 is 3, the square root of 4 is 2, raised to power 1, multiplied by the third root of 27 is 3, then squared. At this point, we'll be having 2 power 3, which is 8, and 3 power 3, which is 27, multiplied by anything power 1 just remains the way it is. This is a 9. So from this point, we can do some simplification. Yeah, we can do some simplification and have the final answer, you know, by 2, 1 and by 2, 4. By 3, 1 and by 3, 9. By 9, 1 and by 9, 1. So you see, we are remaining with 4 at the end of the day. So the final answer is 4. a very easy question to simplify out. You get your marks. Alternatively, how else can you simplify this? Can we start by getting the simplest power of all the bases? Let me pick it from this point. Assume you begin the question by applying the negative law of indices here. You are now at this point. So at this point, allow me simplify all the bases. For instance, 16 over 81. You know, both 16 and 81 can be put under a base of 2 and 3, and both of them have been raised to power 4. 2 power 4 will give us 16, and 3 power 4 will give us 81, meaning that we can write 16 over 81 as 2 out of 3 power 4. So 2 over 3 power 4, and there is already an existing power of 3/4. There is already an existing power of 3/4 multiplied by, in the next question, or in the next term, there is 9 over 4 power 2. You see, 9 over 4 can be put as 3 over 2, and both of them have been squared. So 3 over 2 squared, 3 out of 2 squared. Then there is already a power of half. Multiplied by, now instead of 27, we can have 3 power 3. Then we are already having power what? Instead of 27, 3 power 3, and there is already a power of 2/3. There is already a power of 2/3. Then after that, we apply what we call the product law of indices, whereby the two powers should be multiplied in each case. So we will be having 2/3 raised to power. You see, 4 multiplied by 3/4. The 4 simplifies, and 2 out of 3 shall be cubed. Multiplied by 3 over 2. We have power 2 and also power half. So the power becomes 1. So 3 over 2, power 1. Multiplied by, we are having 3 multiplied by the power, another power of 2 over 3, making the 3 cancel. So 3 will be squared. You see? So we can just simplify and have 8 over 27 by 3 over 2 by 9, and this will cancel to 4. It shall simplify to give us the 4 that we got in the previous. So you can approach it using 2 different approaches, and you will find yourself at the answer. As long as you know how to manage the laws of indices, you are good to go. Now looking at number 5. A circle of radius 4 passes through the vertices of a regular octagon. Determine the area of the circle. Determine the area of the circle that lies outside the octagon. You're supposed to manage area of what you call polygons. It's a very simple concept. And one thing that you're supposed to be very sure about is the name of every polygon and the number it has. Octagon is an 8-sided figure. 8-sided figure, meaning that if you sketch an octagon, you can have 1, 2, 3. That. How many sides are this? I'm just trying to sketch. Let me see. 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, 8 like that. Then you should be able to know that if it's regular, if it is regular, then at the center, we shall be able to subdivide 8 equal triangles. 8 equal triangles. And what shall be the value of the angle at the center of this particular triangle. We extract one triangle like that. Remember, now there is a circle passing through the vertices of each, such that when you extract the triangle, now there is a circle passing like that. Yeah. So each triangle, we can get the angle at the center, ladies and gentlemen. We can get the angle at the center. That angle will be given by, at the center, we have 360. And now we have to divide this by 8 equal triangles. So 360 over 8 is giving us 45. So we have an angle of 45 at the center of each extracted triangle. Remember, the radius of this circle is 4. So we are having 4s here. There is a 4 there and a 4 there. Meaning that we can find the area of the circle which is outside this one, which is outside the triangle. And therefore, we talk about sector. We need theta over 360. Multiplied by pi, multiplied by r squared. Multiplied by r squared. We get an answer. Then we also talk about triangle. We talk about triangle, whereby we need f times a times b, sine of the angle between the two sides. So the sine of 45. Yeah, sine 45. Let's check. So for the sector, we need 45 over 360 multiplied by 22 over 7 multiplied by 4 squared, which is 16. So I'm getting 6 and 2 over 7. 6 and 2 out of 7. What about in the other case, whereby we're having a half multiplied by 4 by 4, then the sine of 45. Now this giving us 5 point 6 5 6 9. See, so now we can 6 and 2 over 7, and we subtract this value so that we know the amount of area which is outside. The amount of area which is outside. So 6 and 2 over 7, we subtract 5.6569. What amount of area is lying outside? This is going to be 0.6289. Those are 4 significant figures. So 0.6289, and this area has to be multiplied by 8. Total area, this shall be 0.6289 multiplied by 8. 8 such areas, and we shall be having 5.0312. To stick to 4SF, we will talk about 5.031 square centimeters. So we're supposed to understand that when we talk about octagon or any other polygon, it's regular, and a circle is touching all the vertices, then it means that that circle is passing in such a way that there is a minor segment. There is a minor segment for every triangle extracted. That area of the minor segment is what lies outside. So we combine all of them. We just treat one triangle because they are all equal. Then universally we multiply by 8 so that you may get the total area which is outside. A very good question, ladies and gentlemen. Remember to comment. Remember to subscribe. Are you getting us clear? If so, where are you getting us from? Please comment. Please comment. Please comment. Let's know Let's know where you are getting us from. Let's know where you're watching us from. How prepared are you for this particular elephant in the house? Are you prepared for the KCSE 2025? Have you been a serious follower of 15 grades? If you've been a serious follower of our programs, you will testify. By the time you'll be doing the exam, you'll be able to talk about how productive our programs are, how predictive, how predictive our presentations are. Remember, from the 20th of November to the 12th of December via Google Meet. You are there, you are a Form 3 heading to Form 4. You are a Form 2 heading to Form 3. This is yours. This is yours. You are there you just finished your KCSE. You want to join junior school. We are inviting you as you transition from primary. We shall build your foundation. Please, please trust us with your children. Trust us with your brothers and sisters. We shall give them the best. This is the best of the best. Aha. At number 6 now. Yes. We are moving very fast. Moving very fast. Aha. 3 alarms, A, B, and C, ring together at 10 a.m. Okay. They ring at intervals of 15, 35, and 50 minutes respectively. How many hours after 10 a.m. will they first ring together again? Not what time, not the time they shall be ringing together, but the interval they will take for them to ring together again. So we need the time which is commonly shared by these alarms if they have the given intervals, and that is none other than the LCM of the intervals. So 15, 35, and 50. 15, 35, and 50. So we find the LCM. 15, 35, and 50. So we start by factorizing. We are having 15, 35, and 50. Those are the intervals. So by 2, 15 cannot be divided, but 35 also cannot be divided. This can become 25. What about 3? 3 can make this one like that. Can we simplify by 5 now? 1, 7, 5, meaning that you can do it by 5 again. 1, 7, 5, and finally by 7. Everything now becomes 1. So we need to talk about 2 multiplied by 3 multiplied by 5 power 2 multiplied by 7. This is the interval in minutes. 2 multiplied by 3 multiplied by 5 squared multiplied by 7, giving us 1050, 1050 minutes. That is the time they will take to ring together again. Now, we just needed this, but now converted to hours. How do we convert to hours? By dividing by 60. And this becomes 17.5. 17.5 hours. 17.5 hours. So that is the interval. That one is the interval. Yeah, the required interval. That is the required interval. Okay. Remember, some other times they will ask you when they shall ring together again, meaning that you shall add this interval to 10 a.m. Again, you can also be asked if they ring together at 10 a.m., when had they rung together? When had they rung together before? Meaning that in such a case, you subtract the interval. So let's be vigilant with all types of settings. It doesn't only have to be the interval that we've worked out. Yeah. They'll ring together after 17 hours. They'll ring together after 17 hours. We can check 17, right? Number 7, sorry. A cylindrical container of diameter 35 and height 20 is 2/5 full of water. 2/5 full of water. The container is filled using a smaller cylindrical can of diameter 7 and height 10. Okay. Find the number of cans. Find the number of cans. That must be drawn in order. That must be drawn. Underline that word. That must be drawn in order to fill the container. This is a very technical question. I know you may think it's simple. You know, this first cylindrical container with a diameter of 35 and a height of 20 is 2/5 full, which means the part that we are filling is 3/5. So the container is 2/5 full, translating to 3/5 empty. It's 3/5 empty. Therefore, we need volume first. We need volume. Being a cylinder, we know that volume is given by cross-section area times height. Cross-section area is pi. You know, I'm thinking something different. Instead of finding the different volumes, why don't we go directly to the number required? In the case where we shall be talking of look at this. We can talk about the number of cans. We need volume to be filled out of volume of 1 can. So that we get the number of cans to fit in this particular volume. So the volume to be filled is 3/5 of the volume of the cylinder now. The volume of the cylindrical container will be pi r. You know, the radius is now 35/2. This is giving us 17.5. Pi r squared multiplied by the height. Pi r squared times the height of 20. This is the volume of the container to be filled. And the filling can is also cylindrical. Yeah. Now the container is to be filled using a smaller cylindrical. Yeah, smaller cylindrical. Meaning that now we talk about cross-section area here. Pi r 3.5 squared times 3.5 once again, multiplied by its height, 10, like that. So from this, we'll be able to compute directly the number of containers. Yeah, the number of containers. The number of containers. Are you guys following us keenly? Where are you following us from? Are you understanding what is happening in this particular broadcast? This is a very good question. This is among the best papers, actually, that we've ever presented. A well thought out paper by the Kisii Diocese. A mathematics joint evaluation. So now from this, even before we proceed to the calculator, can we check whether there are a few things that can simplify out? Yes. So that we work out very little things. So we'll be talking about this one cancelling. The pi cancels because it's appearing on both sides. By 10, 1, by 10, 2. Let's talk about by 3.5, we get 5. And also by 3.5, we get 5 here. So now the denominator is fully simplified. So we are having 3/5, 3/5, multiplied by 5, multiplied by 5, multiplied by 2. So this is going to be 30. It's only 30 cans. It's only 30 cans that are required to fill it, without even knowing the exact volumes to be filled and also the volume of one can. As long as we know the objective of what we are doing, we know the demand statement is looking for the number of cans, then we can get that number even without exact volumes by at the expression level. At the expression level. It's a very good question. At the expression level, you can find your answers. Like that. You can find your answers like that. It's a very good paper. It's a very good question. I want to mention something about these questions, which are usually tested in this manner. Some other times, you shall work out a question, and what you will get is this was an exact number, but some other times you may get 29.8. 29.8 means we wanted the number that must be drawn, must be drawn. So that means exactly 29 cans will not fill the tank, or rather the container. So we must draw the 30th can. We must draw the 30th can. So the answer would still be 30. Even if you get 29.12, the answer would still proceed to 30. We would still round upwards. Why do we round upwards? Because exactly 29 cans shall not fill because it's point something, meaning we shall draw the 30th can, even if we shall not use a lot of it. Even if we will not use it fully, we will handle it. We will need it. We will need the 30th can, even if it was 29.1. Even if it was 29.06, we would still write 30. When you work out a question and you find 30.1 as the answer, then the number of cans would have been rounded off now to the next value, 31. So as long as you get 29 point something and you need the number that must be drawn, you round off to the next value. You round off upwards to the nearest whole number. Upwards. You round upwards. Let's look at some construction here. Oh, sorry. Using a ruler and a pair of compasses only. That means you shall not measure angles using a protractor, right? We'll be constructing angles. Construct trapezium WXYZ such that WX is 5, WZ is 4, then the angle ZWX equals to 30. Then we are also told that XY is parallel to WX. Just a sketch of this information. Just a sketch. Just a sketch. We can look at it this way. This is 5, meaning that WX. Then the angle whereby it is W at the center is 30. Yeah, it is 30. Meaning that 30 is at this point. 30 degrees is at that point. I'm just sketching. We'll get to the real construction. That is there. And something else that we are supposed to understand here is that which other length is given? WZ is 4. So from W to Z, we are having 4. 4 centimeters there. Then Z is there. So Z to Y, the length Z to Y is parallel to WX, meaning that if they are parallel to one another, then we just need to use the approach of what you call the trapezium approach. The trapezium approach, whereby we can have another 30 at this point. Then we make a length of 4 there. You know, with that length of 4, we will be able to produce like that. And, you know, I'm trying to look at the provided instructions. And according to these, we don't have enough instructions for what we call a trapezium. So this is a parallelogram. This one is a parallelogram. It's a parallelogram. Yeah. We can't construct a trapezium unless we are provided with a different length on the numerator or at the top line there, the parallel line at that point. W, X, Y. Yeah. Unless we were given the length ZY, we can't say that this is a trapezium. This one is simply a parallelogram. So we proceed to construct the parallelogram now. This has been resolved too, according to the instructions provided. They are not enough for a trapezium. This is W. Then we measure 5. We measure 5 centimeters. We measure 5 centimeters so that this becomes X. After that, we're supposed to know that the angle where W is at the center is 30. So how do we measure 30? We stand at W. Look at this. We stand at W and we construct 60. We construct 60 first. So how do we construct 60? By making an arc. Then where the arc is cutting the line here, we stand there using the same radius and cut the first arc. You know, when we connect this now to W, we'll be having exactly 60. So that's an angle of 60. Now with an angle of 60, we need to proceed and bisect it. To bisect 60, we just need to stand at these marks. We make an arc, and standing on the other, we also make an arc to bisect the 60. So you produce a line there. You produce a line at that point. Okay. You know, once you produce that line now, you need along the same line, because we need the length from W to Z to be 4 centimeters. WZ to be 4 centimeters. So you measure your 4 centimeters. You measure 4 centimeters. That becomes point Z. That becomes point Z. Now that we are doing a parallelogram, there are several options of doing a parallelogram. Several methods of doing a parallelogram. We can do this by constructing another 30 at X, so that the line at X becomes parallel to the line at W. So we can construct another 30. Yeah, we can construct another 30 by standing here. We make an arc. Then standing here, we cut the arc to produce a 60. Then once we produce the 60 like that, and now bisect the 60, which will give us, bisect the 60, which will give us, standing at those marks now, bisecting 60 will give us 30 degrees. Then we produce the line. So we're having another 30 here. Dot lines are very parallel to one another. At that point now, can we start talking about measuring 4 along this line? Measuring 4 along that line. So that when that measurement of 4, now that is our y. We connect it to z. You find zy and wx are parallel to one another. And by third doing, then we can say wxyz is our parallelogram. So the parallelogram is perfectly constructed. Perfectly constructed. 9. A good question here. The figure below shows a circle center O. Just as we can see, circle center O. Yeah, we can see that. All right. What else? What else? What else? Aha. AOB is a sector. Yeah. Sector is a fraction of a circle. And angle AOB is 84 as shown on the diagram. Given that the area of the sector AOB equals to 10 pi square centimeters, find the radius of the circle to 2SF and hence calculate the area of the shaded part. First, let's find radius. We know that area of a sector. I think this is something we've even dealt with in a previous question in this paper. Theta over 360 pi r squared. So 84 over 360 pi r squared should give us 10 pi because the area is already given. With this, we can talk about now cancelling the pi first from the two sides so that we may remain with r squared. We need 10 multiplied by 360 out of 84. You know, this will give us exactly 42.857. The value of r becoming the square root. So this shall be 6.55. We need it in 2SF. 2SF. Now, not 2dp, 2SF. So this shall be 6.6. Now that we've been told to 2SF, it means in calculating the other things now, the other quantities, we shall use it as a 6.6 and not any other accuracy. So can we talk about now area of triangle? Area of triangle. Check something here with my pen. Area of the triangle shall be half times 6.6 times again 6.6 sine of the angle between the two sides, the sine of 84. Sine of 84. Half multiplied by 6.6 multiplied by 6.6 multiplied by the sine of 84, giving us exactly 21.66 square centimeters. Okay. We have it that way. So can we talk about now area of the shaded part? We need 10 pi minus 21.66. Actually, I'm going to use the pi of the calculator value. Or let me Okay. That way. 31.42 minus 21.66. 31.42. We're getting 9.759 square centimeters. That is now the area of the shaded part. Area of the minor segment, as you can see. Remember the instructions about 2SF are for the radius, not for the final answer, and hence calculate the area of the shaded part. So the shaded part can be given to an accuracy of 4 significant figures. I hope we are together in that. So be very careful when reading instructions, more so instructions about accuracies. Yeah, instructions about accuracies. Look at number 10. The following figure represents part of a pattern. A line of symmetry, L1, of the pattern is also shown. L1 is shown. Complete the pattern and hence state the order of rotational symmetry of the pattern. So if this is the line of symmetry, then we should be able to produce the same object. Or now the image of this on the other side. Like that. And if we follow the same pattern, you discover that now we are supposed to rotate back to the original object. So we have only one image here. You know, in case, let me just show you. According to the Cartesian plane, the number of times it displays itself, the number of times the object displays itself is usually the symmetry, the order of symmetry. So this is order 2. This is order 2. Order 2. Now, in case you found it like this, you're having certain object there. Then now, another one is drawn at this point. Another one like that is drawn at that point. It means you can have another one here, and by the time you're getting back to the original, it can display itself 4 times, and that would have been order 4. Some other times, like in the KCSE 2024, the past exam, it was somewhere here, then another one was here. Meaning that we will just need another one at this point. We just need another one there. And we go back. If we go using the same angle, if we do using the same angle, now we will get back to the original. So meaning that this was order 3. So it depends on the number of times this particular image can display itself before getting back. Display itself using the same angle before getting back. Before getting back to the original objects. So here, it can only display itself twice. 11, number 11. Thank you guys for joining us. Consultation line remains 0704 153366. Yeah, that's our consultation line. Please reach out so that you may know much about our serious programs here for the students. Google Meet is very interactive. I wish you know. I don't know whether you guys have ever been in our programs, and we cover it in mathematics, in all the sciences, and also the languages. So it's a very fruitful program, which I really invite you guys to join. Okay, so we read number 11, which is on commercial arithmetic. This is a currency exchange rates. It's good for you to know that. It's good to know that. There is no way we can have a national exam which is not focusing on commercial arithmetic. That one, just to be sure that it will be fair. Be sure of this. In paper one, even if it will be commission, profits and losses, and then commercial exchange rates, then in paper two, you know the subtopics for paper two. Simple interest, compound interest, hire purchase, appreciation, depreciation, income taxation, and all that. So commercial arithmetic must be considered in any national exam in our country. A Kenyan bank bought and sold foreign currencies on 2 different days as shown below. You can see the 2 different days there. The 2 different days there, you can see them. Then 1 South African rand, you can see 100 Tanzania shillings, you can see. Now, a South African tourist arrived in Kenya on the 24th, 24th of April with 25 South African rands. He changed the whole amount to Kenya shillings, while in Kenya he spent 54,075 Kenya shillings and changed the balance to Tanzania shillings before leaving for Tanzania. Determine in Tanzania shillings the amount that he received. So we first going to convert foreign currency to Kenyan currency. Remember this acronym, foreign currency to Kenyan currency. We use the buying column for cable. Therefore, we will say this, the Kenyan bank buys foreign currencies. Okay, so if it buys foreign currencies, then we will say we are having, the tourist is having 25,000 and each of the South African rands will be bought at 10.08. So if the bank buys at this rate, how much will this gentleman be given? 10.08, right? So I'm getting 252,000 Kenya shillings. That is the amount he's going to get. After getting that, he's going to spend something while in Kenya, accommodations, you know, and other charges in Kenya. This guy might also pay some tax before leaving the country to go to Tanzania. So we subtract this 54,075. We have 197,925. This is now the balance. Now this balance is getting converted to Kenya, to Tanzania shillings now. We know that Kenyan currency to foreign currency, we use the selling column, Kefose. Yeah, Kefose. Kefose. Then now we get back to the table and say this, Let's look at this. One thing that we are supposed to be trying to zoom so that you guys may understand, you guys may see. I hope it's now stable and you can see the paper. I hope you can see the paper. It's my hope that you can see the paper. Yeah, it's my hope that you can see it clearly. Now we are talking of converting 197,925 Kenya shillings to Tanzania money, Tanzania Kenya shillings. Then now we will say this, the bank is going, of course, to sell to you the Tanzania shillings that you need. The bank in Kenya shall sell to these tourists the Tanzania shillings. Now, the bank sells 100 Tanzania shillings at 23, meaning that 1 Tanzania shilling 1 Tanzania shilling is sold at 0.2314. Yeah, it's good we get the rates per unit. So the bank will sell to this tourist because the tourist wants foreign currency now. The bank will sell to this tourist, and we should be able to link effectively and say, at the rate of 100, look at this. This one is a trap. Students must be very careful with it. 100 Tanzania shillings are being sold at 23, which means 1 Tanzania shillings is sold at what? You divide. It's a very cheap currency, you know. So let's talk about 1 Tanzania shilling being sold at that amount. And now a client is having 1979.25. So we need 1979.25 being divided by 0.2314. So that we know the amount in Tanzania shillings that we'll be able to get. So this guy will get 0.2314. We're getting 855,337.08 Tanzania shillings. So that is the amount in Tanzania shillings the gentleman shall receive. It's a very technical conversion, more so when you are not careful with this value here, 100 Tanzania shillings. You start thinking that it is 1 Tanzania shillings. That's how you will mess up. So please be careful with all conversions. Be careful. Read every question into details. Read questions into details. Let questions be read into details. Let questions be read into details. Okay, number 12, guys. Given that, or given the column vectors of P, Q, and R, and we are also told that a vector A is given by 2P minus 3/4 of Q plus 2/3 of R. Express vector A is a column vector, and hence evaluate its magnitude, the magnitude of A. Remember, you can also be told to evaluate, and they cancel this. You should be able to interpret the mathematical signposts very well. Okay, yeah, you should be able to interpret mathematical signposts very well. Interpret mathematical signposts effectively. Okay, let's first find A. We find A first. A is given by 2P, then minus 3/4 of Q, then plus 2/3 of R, 6, -9. We can compute now. We can compute before we add and subtract. Or actually, we can say vector A equals to, this is -4. Then in the next 3/4 and 12, it will be -9. Then the next shall be 2/3 and 6 shall be +4. Yeah. Then on the other side, the x component, 2 by 3, 6, 3/4 of 8, that will be -6. Then 2/3 of -9 shall be -6. It shall be -6. Like that. Magnitude A. Okay, vector A. We're finding the vector A first. So the vector A shall be -4 minus 9 plus 4. That becomes -9. Then 6 minus 6, then -6. You know, 6 minus 6 becomes a 0. Then now we remain with a negative 6. So when we are talking about magnitude now, we should talk about minus 9 squared plus a negative 6 squared. Then we take the square root. Yeah. So, evaluate the magnitude. So 9 squared plus 6 squared, we get the square root of 117 units. Yeah, that can even be our final answer because we've not been told to a certain accuracy of all that. No further instructions. And without further instructions, ladies and gentlemen, you can even leave it as sad form. Though remember, you can still put it as to 4SF 10.82. So that is the length of the vector. That is the length of the vector. But the most important thing, know how to multiply vectors by scalar multiples. Number 13, ladies and gentlemen, number 13. Remember, very soon we shall be projecting a paper 1 section 2. Very soon, a paper 1 section 2, just for your guidance, for you to stay on toes, for you to stay well guided. Yeah, for you to stay well guided. Solve the following simultaneous equations by substitution method. It's good for you to know how to solve simultaneous equations using all the methods. When we talk about substitution method, we just express one of the unknowns in terms of the other, and it should be any unknown from any of the equations. Sometimes the examiner can direct you by expressing x in the first equation, solve the following pair of simultaneous equations. But in our case here, nobody has commanded us to express any. So now we make a decision, right? Which of the variables, or rather, which of the unknowns is easier to express? We prefer the one with a coefficient that can divide through very easily, more so a coefficient of 1, 2, multiples of 5. So when you look at the second equation, you know we have 1 here and we have 2 here. So when you look at the second equation, can we express the value of y? We bring y here, then we have 5x and the 11 is subtracted. 5x minus 11 like that. So because this is from equation 2, that's from equation 2. Now we rewrite equation 1 using the value of y as 5x minus 11. So equation 1 can be rewritten 4x plus 3, and instead of y, 5x minus 11. 5x minus 11 equals to 5. Can we open brackets, group terms? 4x plus 15x minus 33 equals to 5. Grouping terms means 19. Grouping terms means 19x. Let me check with her. Yeah. Grouping terms means 19x. Means 19x. Then this is equal to 5 plus 33, giving us 38 positive. So it becomes 38 positive. Can we get the value of x, guys? We divide through by 19. So 38 divided by 19 is just 2. So the value of x has already been found as 2. And with the value of x, we can find the value of y. There is the expression that gives us the value of y. It's here. This one gives us the value of y. So 5, instead of x, we have known that x is 2 minus 11 to give us y. Okay. So with this now, can we talk about 10 minus 11? equals to y, and the value of y becomes -1. So the value of y is exactly -1. A very good question. A very wonderful question, ladies and gentlemen. We check number 14 now. We check number 14, okay? Now the figure alongside shows a right-angled triangle ABC. The dimensions of the triangle in centimeters are given in terms of k. K plus 4, 2k minus 1, k plus 1. Remember, we've been told that it is right-angled. Determine part A, the value of k, and part B, the perimeter of the triangle. So to get the value of k, we use Pythagoras theorem, whereby we say the value of k plus 4 squared plus k plus 1 squared should give us the hypotenuse, also squared. That is according to the Pythagoras theorem. When you square the two sides, the two short sides, and you add them, you get the hypotenuse also squared. You get the hypotenuse also squared. Can we expand now? Yeah, we can expand. This becomes k squared plus 8k plus 16 plus, in the second one, k becomes squared plus 2k plus 1 equals 2. On the right-hand side, this will be 4k squared minus 4k plus 1. Yeah, minus 4k plus 1. Can we get into the business of grouping terms together now? It's my hope that you know the expansion, the quadratic identities that we use to expand without wasting a lot of time. When you are given a plus b squared, you just get the value of a squared plus 2ab plus b squared. So you can expand generally. You can just expand generally that way. You can just expand generally that way. So I've applied that general identity that is used in the expansion. Yeah, that is used in the expansion. Grouping terms together. Grouping terms together. We can talk about k squared and k squared being combined here. So 4k minus 2k squared, we get 2k squared. Can we check something else? This is 8. And this is 2, giving us 10. Then we are having -4 here. So -4 minus 10 when we group together. This will become minus 14k. Minus 4 minus 10. Minus 4 minus 10, yeah. Then finally, the constants. Finally, the constants, we have 16 and we have 1, giving us 17. And this is 1. So we get -16 because it's 1 minus 17. Get -16. We've remained with a 0 here. Can we simplify? Can we make it simpler? This equation can be made simpler, and that will be k squared minus 7k minus 8 equals to 0. Can we solve it using product and sum? If product and sum, or rather the factorization doesn't work, we can try other methods like completing the square. A product of -8 and a sum of -7. We have any terms whose sum is negative, whose product is -8 and sum -7. Can we talk about -8 and +1? Product -8, sum -7, yeah. So k squared minus 8k plus k minus 8 equals to 0. we can talk about in the first two, k factored out to remain with k minus 8. Then plus just 1, so that we have k minus 8. Everything here is equal to 0. Everything there is equal to 0. Let's talk about now from inside the brackets. K minus 8. K minus 8. Then outside the brackets, we are having k and a positive 1 equals to 0. Using the first expression, k equals to 8. The value of k equals to 8. And using the second one, the value of k equals to negative 1. Now that we are dealing with length, we can't have a negative length. Okay, just a minute. Yeah, we can have. Can we have a negative k? Let's examine. When we use a negative 1, this length will become 0. And it's not practically possible to have a length equivalent to 0. Like a dimension cannot be equal to 0. It can't be equal to 0. We can't have a rectangle where there is no one side. So that is not practically possible. And even when you substitute in the hypotenuse will become a negative. So we can't have a negative side. We can't have a negative measurement. So allow me talk about settling on the value of k as 8. So that now we can find the perimeter. For us to find perimeter, we need to find now the actual lengths. K plus 4, this is 12. K plus 1, this is 9. 18 minus 1, this is 17. 16 minus 1. 16 minus 1, that's 15. 12 squared plus 9 squared, getting 225. And 15 squared is 225. So we've done it very well. It satisfies the Pythagoras theorem. So we can find now perimeter, whereby one length is 9, another one is 12, and another one is 15. So we're talking about now 9, 12, and 15, 36 centimeters. Yeah, the measurements are in centimeters, so 36 centimeters. It's a very good question. We're supposed to know how many concepts are we involving here? There is Pythagoras theorem, then it later becomes quadratic. Then now we have perimeter on measurements. So a very involving question. Thank you for following. We are almost winding up. Please ensure to subscribe and also to share so that you may invite a few guys to our wonderful programs. Now, 3 business ladies, Janet, Christine, and Judith, contributed 100,000, 120,000, and also 130,000 respectively to start a business. The profits made each month was shared in the ratio of their contributions. During a certain month, Christine received 32,760 more than Janet got. And I would like to know the kind of business they really ventured into, because if you just contribute 100,000, 20,000, and 130,000, then all of a sudden, in just 1 month, somebody is receiving 32,000 more than. This is not what she received. It is more than. There's a difference between 2 people. Then it means these guys are really earning a lot. People are rich out here just because of venturing into some businesses. So it's a business that I would like to would like to try. I wish the setup of the question gave us the contacts for Janet, Christine, Judith. But look at this. Look at this. When we check their ratios of contribution, you know, there is Janet, there is Christine, and there is Judith. So 100,000. There is 120,000. There is 130,000. Okay. So ratios are supposed to be in simplest forms. Let's first divide the thousands. We divide and remain with 100, 120, and 13. So we can simplify to 10, 12, and 13, which can't simplify further. So this is the ratios of their contributions. Now we are told that Christine received more than Janet. Christine more than Janet, okay? The first one is Janet. Okay. So written, this is Judith. All right. So now we'll be able to talk about the difference between Christine and Janet. According to proportions, their difference is only 2. We have 12 proportions and 10 proportions. So the difference in proportions is 2. So 2 proportions is being represented by 32,760. So we consider the difference in proportions to represent the difference in what they received. The difference in proportions to represent the difference in what they received. Determine Judith's share. So Judith is receiving 13 proportions then. So what about 13 proportions? So 32,760 by 13 proportions out of 2. Just look at this per month. Look at this per month. 32,760 multiplied by 13 out of 2. We are getting 212,940. So within a month, somebody has already recovered the capital that they gave to start the business. It's a very good question. Now, as you handle these questions, you should open your minds and see what people are doing out there. So next time, let the setters tell us that 3 business ladies, Janet, Christine, and Judith, contributed to start a business. Let them tell us the business that was started. 16. The angle of elevation. The angle of elevation of the top of a building from a point A is 18.5 degrees. Now, the angle of elevation of the top of the building from another point B is 50.6. Now, point B is supposed to be closer to the building because the closer you get to a vertical wall, the greater the angle of elevation becomes. If point B is 20 from the base of the building, calculate to 1 decimal place. So you see, these are universal instructions about 1 decimal place. It's for both part A and B. It is just not attached to part A. It is a universal instruction. So we're supposed to be very careful when reading instructions, more so about accuracies. The height of the building and also the distance between A and B. Let's check a sketch of this. Let's see a sketch of this. We have a building here, ladies and gentlemen. Then there is a point here and another point. You know, we are assuming point A and B are on the same horizontal ground. Therefore, point A is here, where the angle of elevation is 18.5. Then B is here, where the angle now increases to 50.6. And now we are told that the point B is 20 from the base of the building. So we have 20 here from the base of the building. So this is where the building is. So now, what is the height of the building? We apply trigonometry, and I think tangent will help us here because the tan of 50.6 degrees equals to opposite, which is the height unknown, out of the adjacent length to this angle, which is 20. So how shall you remain with h? You can't get h. until you multiply 20 by the tan of 50.6. Yeah, until you multiply that. So 20 tan 50.6 is going to be 24.35. 24.35. Okay, 24.348. We've been told to one decimal place. So 24.3 meters. That is the total height of the building. So the height of the building is expressed by 20 tan 50.6. 20 tan 50.6. That way. 20 tan 50.6. That is the height, the value of the height. To 1 dp, it's given here. Part B, the distance between A and B. So the first thing that we're supposed to find here is the distance from A to the building. A to the base, A to the building. So the distance A to the building, from A all the way to the building, which can be let to be X. We need to talk about the tan again of 18.5 to be equal to opposite. Is 20, the exact value, apart from the rounded off value, out of the unknown X. So to get the X, we need 20 tan 50 out of the tan of 18.5. So the value of X equals to, this we divide by the tan of 18.5, giving us 72.77 meters. So we are to find it to 1 dp. So remember, this is now 72.8 meters. But again, we're supposed to now talk about distance from A to B, which is supposed to be 72.8 minus 20. Yeah, from A to B now. Remember, the total X is 72.8. What about now from A to B? You subtract the distance of a 20 there. We subtract 20 and we get 50.8, 52.8 meters. So that is the paper. That is the section 1. A very good paper, very interactive. It's my hope that you guys have gained something. I continue wishing you well as you prepare for the KCSE 2025. So thank you so much. See you another time. Continue perusing through our channel so that you may get a variety of predictions for mathematics paper 1 and also paper 2, physics paper 1 and also physics paper 2, and also physics paper 3 prediction models. We are already having them. You can reach out through 0704 15 33 66. Thank you. See you another time.